sometimes the highest payoff is not the best. What do I mean by that? Well, we know for one thing that just simply calculating a payoff in cash, it may appear to be the highest one, but there's other factors that can affect it. We talked about externalities, direct externalities that can affect it in a negative way, for example, and lower the payoff. We've talked about non-monetary factors that can impact the payoff. There's also this factor of risk. There's a principle in philosophy picked up in game theory called the maximum principle. What the maximum principle means is basically this. You take a look at all the possible outcomes and you choose the outcome that has the least amount of negative factors in it. In other words, you're like Eeyore. Everything's going wrong. That's Eeyore in Winnie the Pooh. You're going to choose that solution or that path or that outcome where the least amount of things will go wrong. It is a very risk-averse position. The flip side is the minimax side. There you look for all the really best outcomes. You're not risk-averse and you're saying, okay, I'm going to step those down and take only those that are lower in risk. So I'm going to take the least amount of risk given the best outcomes I can get versus the highest of the least negative. I'm looking at good things rather than negative things, and I'm trying to peg the risk. And the way I measure that risk that I'm pegging is obviously the discount rate. Now, even after we do that, we still have some issues with the payoffs. And the issues are the probabilities that we assign to events that can happen. Let me give you an example. You're getting ready to go to work in the morning. It's very icy outside, and you go into the car, and you suddenly realize there's a 90% chance you can have a horrible accident and kill yourself, and a 10% chance you'll make it okay. You're going to think twice before you drive off to work, and you may not leave that day. You may go home, call in sick, or call in for the weather or whatever. If we take this back into the context of business and doing deals in the context of commercializing a technology, there may be event nodes where, if we look at it, one path has really disastrous consequences, the other one doesn't. We can calculate out the value using the probability distribution, saying this, whatever the value on this path is, and this is 10% likely, that's one value, and here's the value on the 90% chance, and that's 90% likely, and we put those together, and voila, we have the value at that node. But nonetheless, we may choose to just lop the whole node off from that whole pathway off and say, we're not even going to look at that because we don't want to bear those kind of risks. That's just above our risk threshold. What does this mean? Well, peace of mind counts for something is one thing it means. The other thing it means is when we go back to look at our game and we're trying to do a deal and we're looking at the payoffs, we have to consider at least three things. The first thing we have to consider is what's the cash payoff once you convert everything you can convert to cash. The second thing is, are the utilities that are going to skew the best payoff, best now rather than highest payoff? And finally, what's the risk profile of the player? Because the risk profile can also skew what best means. Excuse me. So where do we end up? Well, if we're trying to put a deal together and we're looking at the payoffs, we have to look at all the strategies, everything that our target can do, the person we're negotiating with or we're trying to get into the deal. We look at everything they can do and say, how can we behave, given what we know about them, to move them into an area where we would like to end up? So we're looking at all their strategies and saying, given all these strategies, what can I do to optimize the outcomes so that I get the best outcome, however I define that. And if I can't figure out how to get my best outcome, then I look at my second best outcome and my third best outcome and so on. Meanwhile, they're probably doing the same. They want their best outcome, or at least what I see as their best outcome, since I'm doing the game as a planning exercise rather than a real game. And they're looking at the next best and the third best and so on. When we find that outcome, which is the best possible outcome I can get, given all the other strategies on the other side, and they look and they say, here's the best possible outcome I can get given all the strategies that I'm going to do. If those two end up being the same, we can do a deal. That's what we call a Nash equilibrium, where the strategy you choose is the best strategy given all the other strategies that are possible, given everything else that the other party may do, and they choose that strategy, which is the best possible strategy given all the things you can do, and they happen to be the same. Sometimes there's not a single Nash equilibrium, as we saw way back when we introduced this topic in the initial section on games. There we saw typically in deals there's two Nash equilibriums. One's do the deal, one's walk away very quickly and don't do the deal. The reason we can't choose between those two is there's a certain point at which there's no way to determine which strategy is likely to occur on their side, so we have to allow for options. Now, we can look at those two strategy options, those two equilibriums, and say, is there a Schelling point? A Schelling point simply means the Nash equilibrium most people would prefer. If we're doing an economic transaction, the presumption is people want to make money. The Schelling point is the one that has the highest cash payouts for both parties, so do the deal is likely to be superior to not doing the deal. But again, it all depends, and we never have perfect information. We never have perfect knowledge, and no matter how much we do, we can't have that. So part of it's just a guess. The trick is to be real clear about what your guesses are, define them clearly, understand the risks you're taking. The other thing that's important in this trick, if you're going to play games like this, a game called commercialization, is you got to be real clear what it means to win for you. You want to define up front what a successful outcome means. What's the minimum good outcome you will accept? If you know what that minimum good outcome is, that's the maxi of the mins, where the worst possible outcomes are avoided, or the minimum of the max, where the best possible outcome with the least risk or risk down to the level you're willing to bear is obtained, then you can do the deal. By the way, a min-max is not necessarily the same as a max-min because they're calculated differently. But when you can do that deal, if there's a Nash equilibrium there, that's when the technology will move to market. We're going to very briefly in the next session look at how you would graph this, and that'll be the end of our initial discussion of games until we come back to this topic later on in the videos and we talk about strategy. But first we need to go and start looking at market research. See you in a few secs.